One more piece of candy, I think. Find the volume on exercise 4 of the solid formed by revolving the region bounded by f of x is equal to 2 minus x squared and g of x is equal to 1 about the line y equals 1. So here's an opportunity to revolve something around an axis that's not the x-axis or the y-axis. We'll start, as we do, by drawing a picture. Just got to have a sketch, right? Just sketch out something. And we've got a parabola. It is 2 minus x squared. So it's upside down. It's up 2. So what did it do? So sort of like, we'll say this guy right there was perfect. All right, and y is equal to, or g of x is equal to 1. It's going to be this line that's right there. So here's our plane region, this shape. And we're actually going to revolve it around the line y is equal to y is equal to 1. Yes, there you go. Y equals 1. All right, and so I don't have to worry about all of this other stuff that's down here for this parabola. This thing is going to revolve around just that line y equals 1. So I'll start by drawing in a rectangle here. Doop, 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 doop. And then when we revolve this thing around, you know what? This time, here's another thing that I sometimes do. I just extend this thing out and I visualize what this thing is going to look like over here so I don't have to mess up this picture. I don't know why I didn't do that before. Maybe it's time to just re-record all those videos I just recorded. Except not. All right, so I'm going to revolve this thing. It's going to hit like right about there. And then there. Oh, it's perfect. All right, so yeah, there you go. So visualize that this thing is taking place inside of there. Okay, what information do you need? You need a radius, you need a height. So the height is probably the easier part here because this is a horizontal axis of revolution, which means that our represented rectangles are perpendicular to it. They're going to be vertical. And so it's a change in x right there. So change in x, right? And then I also need a radius length. Okay, so here's where that whole thing that we did with the area between two curves is going to come in pretty handy. So I'm going to sketch this thing right over here. So you can see that, again, it's just basically the top minus the bottom. This top piece was 2 minus x squared, and then we want to subtract out the bottom one, which is 1 minus 1. And then you can, of course, simplify that to 1 minus x squared. And we're ready to integrate, to find the volume. All right, I'm going to have to switch this back to, yeah, there we go. So our volume is equal to pi, definite integral, from 0 to, what am I integrating with respect? Oh, yeah, it's from -2. Is it -2? Oh, I got to solve this. I got to find out where these things intersect. I think it's 1. Yeah, so where is 2 minus x squared equal to 1? Here, let's add the x squared over, subtract. 1 is equal to x squared. X is equal to plus or minus 1. Well, I guessed it right, as if I'm just pretending. I'm pretending like I didn't know what the heck I was doing. Yeah, from there to there. So why did I do 0? I'll tell you why I did a 0. Because since this thing is even and it's symmetric to the y-axis, we can shortcut this just a little bit, as you're going to see. We need our radius function, which we're going to square, 1 minus x squared, and then dx. So this is what I'm talking about. See, we're symmetric to the y-axis, both in terms of our interval and in terms of our function. So we could turn this into 2 pi, definite integral from 0 to 1, of this function being squared. Let's go ahead and square this thing out. Why is that helpful? Because it's so much easier to have to just plug in 0 in this polynomial rather than a -1 and miss something because of a negative sign. All right, I'm going to have 1 minus 2x squared plus x squared squared, x to the fourth dx, which is equal to 2 pi. Let's take the antiderivative. That'll be x minus 2x cubed over 3, and then plus x to the fifth over 5. This is handy because all we have to really do is stick in 1. Stick in 0, they all cancel out, so I'm going to ignore it, kind of like it did on that previous exercise. So 2 pi, 1 minus 2/3 plus a fifth. Okay, so I'll just get a common denominator. Yes, you could save stop this, but yeah, no. 2 pi, let's 15. So this would be 15 over 15 minus, that would be 10 over 15, and then plus 1, no, 3 over 15. Right. That would be 15 minus 10 gives us a 5, plus 3 more is 8/15. Multiply that times the 2 pi gives us 16 pi over 15, and then throw in our units cubed. Dun, da, da, da. So what piece of candy does this look like, ladies and gentlemen, boys and girls? I wonder, does it look sort of like, okay, so here's a nice picture of all of this, right? Okay, yes. What does that look like to you? Well, if you were born in, say, like the 1940s or something, you might say that that looked like a lemon head, some kind of lemon drop or something, that kind of candy. And these things, they're quite delicious. They're a little bit sour. Do you like those like Sour Patch kind of candies? It's a little bit sour because they're lemony. But yeah, that's how they make those candies basically as a solid of revolution. Okay, that ends the disk method. What we're going to do in the next couple of videos is we're going to see is what happens when there's a little hole in it. We have to use the washer method.